In episode 2, where we talked about if statements and switch statements, I briefly used an error in the shorthand notation form of an if statement, but I didn't fully talk about what they are and how they work. Even though it should be pretty clear from the name what an error is, they are somewhat different or somewhat unique compared to other programming languages. So you might have seen this one before: if error does not equal nil, then we do something. You also might have seen people on Hacker News, Reddit, Twitter, whatever, hate on the amount of time that you need to write this statement. So let me break down why this is actually good, what errors are, and what errors as values mean, so you have a proper mental model of how to think about them. First, I want to tackle this if error equals nil debacle, because Go forces you to deal with errors when they occur and not later on in your program through some like catch-all function. This is a great thing. This is good. It makes it obvious where something went wrong and requires a conscient decision as to what to do next. Often you just return the error and let the caller deal with it. So I want to give you an example of this. So say we have a API package here. I'm just going to call this one api.go. API, and in here we have something like func new user. It just takes in an argument of name, that's a string, and returns an error. And then we are going to call the database. We're going to say error equals database insert user. Now this is obviously pseudocode. We're going to have a lot of errors here.
Hi, Morten here. Sorry to interrupt. I just want to tell you about my course, Master Full Stack Golang, from which this video is a part of. We start completely from scratch and progressively build up to a production-ready block that you will deploy on your own server, and we will cover things like databases, authentication, SEO setup, and much more. So, if you want to learn full-stack web development in Go and become a professional web developer, go to mastergolang.com and get started today. Now, back to the video.
So just stick with me. I'm also going to create like a pseudo database package here, database, and let's just call this one db.go, package database, and we have a function here called insert user that takes in a name and returns an error, and then we have some code for executing SQL against the DB. And for this example, I'm just going to return an error so I can illustrate the concept. So we just say could not insert record. Now I can go back to API and we can actually import this, and we see we have this this error right here. So first of all, where should we handle this error? The reason why our database insert user function could error is multiple, but we can't really do much in the database package to fix it in a logical way. It makes a lot more sense to deal with this in the API layer, where we can return like a message to the user. We can retry if we want to, right? So for the database insert function here, it makes a lot more sense that we're going to return it to the caller, which in this case is the new user function in the API layer. So as I mentioned, the new user function could return a helpful message to the user. It could issue a retry. But how would we as the programmers know that an error has occurred? And this is where we have observability or logging. Go has a package in the standard library called slug, which gives us different options for outputting information that is not available to the user. So that sounds great, but where should we log? Because we have two places where we have the same error in a sense, right? A good rule of thumb is that we log something where we handle it. So in this case, we just argued that in the database package here, we can't really do much about this error. We can only really return it. So the only place we realistically handle this error is inside this new user function. And how we go about it, well, as I said, we have multiple options, but it makes sense that we handle this error here. So if we were to say if error does not equal nil, then we can return a new error here saying could not create a new user. Please try again. And then we import this errors package from the standard library as well. Now, it's important that we are strategic about where we log. Because if we log too much, the information is going to get lost in a lot of in a lot of logs, right? So here we could simply say, after we return this message to the user, slug info, and then we say an error occurred while inserting user in database. We have some context, and then we say the error was error. All right, so here this slug.info never gets outputted to the user. It only something that gets outputted to us as the programmers and the maintainers, and then the user will see this could not create new user, please try again message. Now, if you were to log this as well in the database, you can see how we kind of will have the same log twice, right? So we have even more information we need to pass, look through, determine where something happened. Here is very clear that we called this function from the database package. We were trying to make an insert and something went wrong, and then we have the error, and we can go into the package and then fix that error. I said earlier that errors are values, which means that we can examine the type of error by looking at its value. Now, say this error we get right here is related to, I don't know, database connections. This is obviously not the fault of the users, but something that we, the developers, should fix. In that case, we can actually change what is known as the log level to go from info to error, because this is an actual error that we need to look into, right? But how do we know? That this error is related to connections? Well, if we were to go into insert user here, we could create a new variable, say error connection failure, and say errors new. The database connection was, I don't know, it was dropped, right? So this is our own custom error. But we would typically also use a package or something that connects or actually interfaces with the actual database. So if we were to mimic this with some more pseudocode here, we could say error equals, let's just say we have a DB package in here, right? DB, and that DB package has an exec function that lets us run some SQL. So insert into users, name, values. It's gonna be just $1 because we are gonna be mimicking Postgres, and then the name. Now, our error handling here, we can actually look at the specific type of error. So if error is not nil, we can use the switch here and say, oh, I need to spell switch correctly. Switch, there we go. And say, let's say case error, then we can use the error is, which just check directly what the error is. So if error is, let's say we have a DB connection error, in that case we return error connection failure. We might have other errors as well, right? We could also have, let me copy paste this one and say we have a record exist, and saying something like matching records already exist, right? Then again, we can say that, or in this case, like in this figuratively case here, that our DB package has a error. This is record exist. And now return error record exist. There we go. And if it's none of these errors, we just return nil. Great. Now we can go back into our API package, and then we can say pretty much the same thing as before. We said switch, and now if error case error is database error, we have connection failure, then we can return a more specific error message to the user, something like an error occurred on our end. Please try again. There we go. And we could also, since we now have the option to look at if the data that the user provided was bad, we could say errors is error database error record exist, and now we can return a more specific error message for that case. So our user, let's say with that name, already exists. Right. And even more now, we can also adjust the logs that we output. So here we would clearly have an error occurred because this is something on our end. Now you can argue if you want to add a log here saying user tried to insert a record that already existed. There we go. Whether or not you want to do this, that's up to you. But now you have the option, and you can do more detailed or more correct outputs of whatever went wrong, both to you as the programmer, but also to the user. And then we can just have a catch-all down here, where we could not create the user. Please try again. Now, as I already mentioned, we are using a figurative error package in this case to mimic the behavior of a real database package. And I know we have database twice here, but stick with me because I'm just trying to illustrate the concept of how you can deal with errors at different levels. But say that this DB package here also outputted we can see they have like concrete errors, right? Like connection error, record exist error, and in that case we might want to bring that information up to the higher level to give us more information. In that case we can use this errors join, where we can add an error, and then we can add our own error, and we can add multiple errors to this error chain or error tree. And then here do the same with our record exist, so we can provide more context if we actually wanted to. This is a really helpful behavior, so you can get like the full picture of all the errors that occurred if you ever need to. Great. This might look a bit unnecessary, and this is definitely a thought up example. We are going to deal with it differently in the actual course. But say that we were to change the SQL package, the package that we use for executing SQL against the database, right? That package might have different errors. And if you start to rely on these errors, well, if you change that package, we break pretty much everything. But by creating our own errors here, we can rely on those errors and then just switch it around in this specific function if there is anything to switch if the errors changes. Now, we made this join so we always have the context of our own errors, but also this more specific errors of the package. What we need to do now is we need to use what is known as errors as instead of is. Errors as will look for the first error in the error tree that matches the error we provided here. and will only return true if it finds that error. So we might have a ton of errors in this error chain or error tree, but we know that, okay, we know that this error can happen, and if that error happens, we want to do something specific. We still have everything that happened in this value right here. So this will have everything that happened up to this point, and then we can examine the output of that error in our logs, right? But we know that if it contains error connection failure, then we need to return this error message, right? So errors as is a really good tool if you have multiple errors. Errors is really good if you only have one error. This all definitely takes a bit of practice, and these examples I've shown you right here is not really real world examples. It's more illustrative, but follow the guidelines here of trying to handle the error where it's or trying to log the error where it's handled, and try to handle it in a place where it makes sense. And then again, that takes practice, right? Because where does something make sense to handle? You could argue that it makes sense to handle in the database, but it also depends on if the function can do something, right? And in the case of a record exist or connection failure, we don't know what to do because we can't fix it in the database layer. We can't fix it in the API layer. We can only really return a message here saying like this record exists, or let us, the programmers, know that there's a connection failure, and we need to look into how our database is configured. So this is a very short intro to errors. We will use them a lot throughout the development of this blog, so you will get to become very familiar with how you can work with errors in a professional way.